Hi there. This set of videos is about using the CEDriverWizTemplates as available on Codeplex. In a nutshell, these templates simplify the development of a simple stream driver for Windows Embedded Compact 7 and provide a number of test applications. This video is about setting the scene for using the templates, that is, why use them. In developing an embedded image for Windows Embedded Compact 7, we use Platform Builder installed with Visual Studio. So you would firstly develop the operating system image using out-of-the-box and third-party components. Out-of-the-box means just those components that are supplied when you install Platform Builder. You then would go on and create your custom device drivers for any hardware, etc. that is not provided out of the box or by a third-party component. Having got your operating system up and running with all the required device drivers, you then would implement your various applications required by your operating system running on your particular device. And you then focus on deploying the whole operating system with its applications, device drivers and so forth to the target device. This wizard focuses on being able to create custom device drivers. Let's just have a brief look at device drivers. A device driver is an interface between the operating system and the underlying hardware. When a device driver is loaded, applications and the operating system then use that device driver to interact with the hardware. Device drivers in Windows Embedded Compact and Windows CE can be looked at on a number of different dimensions. There are device drivers that are native, and there are device drivers that are stream drivers. Native tend to be specific to the particular hardware that's required, for example video and so forth. The stream drivers are where they can be made to fit to a standard interface for the operating system. Secondly, device drivers can be monolithic or they can be layered drivers. Monolithic is where the whole device driver is just one piece, one DLL that is. Alternatively, device drivers can be layered, and this is useful for where the particularly the driver is broken up into two parts: the interface to the operating system and the second part being the interface to the hardware. So we've focused with this wizard on stream drivers because stream drivers have a standardized interface. The other thing with Windows Embedded Compact 7 is to consider whether the device driver is going to run in kernel mode or user mode. This option is facilitated by the wizard, quite simply. So we're looking at stream drivers. Stream drivers provide a standardized interface, standard implementation. So they all have the same basic architecture from a software perspective, which makes the implementation simpler than trying to build a native driver. So with stream drivers, there are the actual standard stream, generic stream that we can create. There are your block drivers for storage, your bus drivers where different devices are connected to the same bus or sub buses, and USB drivers. They're all stream drivers. So some specific examples of stream drivers is just a generic stream driver that you may invent for some general purpose. serial drivers, stream drivers, power can be implemented as stream driver. Audio is streamed, which makes sense now because audio is going to be passed around as a stream. The LEDs for embedded hardware are also another example of stream drivers. So the stream drivers have a stream interface, and the stream driver is implemented as a native DLL that implements a set or subset of functions. So a stream driver has to have a init function and a dinit function. These are what are called by the operating system when the stream driver is loaded and unloaded. To access, for an application to actually access data and manipulate the stream driver, there is the open and close functions that the stream interface needs to implement. To actually move data in and out of the stream driver and to do lower level controls and also do data movement, there are the functions read, write, IO and IO control. IO control uses what are called ioctls. There are some of these functions that are optional, in particular the power up and power down functions, which can be implemented. Generally though, you might find that power is actually implemented as an interface through the IO control function. Finally, there are some optional functions of pre-init and pre-close, which take care of housework just before the driver is unloaded with pre-dinit and just before it's closed with pre-close. These can be in particular used for looking for threads that are running, just making sure they're shut down before the actual closing or shutting down of the driver occurs. Stream driver also requires some registry settings to specify some configuration issues to do with the driver. There's the DLL name, there's the prefix. The prefix, for example, like a serial driver will use a COM prefix. That's where we get the COM1 or COM2, COM3 colon. There are various flags. Some of these, for example, specify whether the driver is going to load in kernel or user mode. And also we can specify the various IO control interfaces are implemented by this driver, and the operating system can then exploit them. For example, the power interface might be implemented. So we use Platform Builder installed as an add-on to Visual Studio 2008 for Windows Embedded Compact 7. Using this, we specify the operating system, we build, we deploy it to a test environment, and we test the operating system and harden it. We develop our custom device drivers, and we do the application development, which can be native applications or managed code, as in .NET Compact Framework. And so we see here a typical operating system design implemented as a solution in Visual Studio. We have all the operating system stuff here, and we can create sub-projects of the operating system, applications and application DLLs or device drivers and so forth. And finally, down the bottom we have the parameter files for the operating system that are not part of drivers and so forth. If we create a custom driver, then we would, if we wanted to load at start time, we would put its bib entries in the bib file here, and we'd put its registry entries in this file here, build the operating system, and it would start and run. I have a couple of gripes though, and this is the reason for developing the CEDriver wizards. Firstly, I have a gripe about adding custom sub-projects. Yes, you can add your own sub-projects, but you're constrained to what's available. Also, running sub-projects. Whilst we can right-click here and add certain types of projects, those sorts of types of projects is not extensible. That is, third parties can't create those. Secondly, having created a sub-project application, wouldn't it be nice if you could just right-click here and say run, rather than having to go through the other ways of doing it, which we'll see in a moment. So we should be able to do both of these from the sub-projects tree here, that is, create custom sub-projects and run them from here without having to go elsewhere. So I'd love to have some right-click context here. So they're my gripes. Let's now expand on this topic. Here we have a Windows Embedded Compact 7 project. At the moment there are no sub-projects. If I right click on here, I get the option of adding an existing sub-project or adding a new sub-project. Let me first just add an existing sub-project. So I right click on here, I browse into where I've got them. Here I've got a CEDriver project, and I can either click on the sources or the PBP XML file, and I'll click on sources, and the project has been added, and I now have a CEDriver project which I can build. If we have a look at that, we'll see some of the functions that was mentioned previously. Here's the pre-close function, the close function, the deinit, preinit, and here's the init function. Note that the names of these functions, as I mentioned previously, are prepended with the prefix of the stream. In this case, the stream prefix would be XXX, which means the first one to load would be XX1:. If this was a serial driver, this is obviously be com_init. So essentially, we implement these functions, and you can see that they're just implemented as a simple shell, returning the required value that makes sure that the operating system doesn't treat the core as a failure. So in this case we're returning 1 when we open, in which case the operating system would say okay, it did open it. If we'd return 0, the operating system would have returned saying couldn't open the driver. The power down, power up functions. Here's some read write functions. In this case it's reading from a buffer. It reads a certain number of bytes and returns those. The write does the reverse of that. It actually writes the values into the buffer. And we have down here, here's the ioctl control function, and it looks for certain ioctls. When there's a call for a certain ioctl, if it finds it, it reports OK, otherwise it reports no, didn't work. So we return a false. If the octal is found, it returns a true. If the octal by default is not found, it returns a false. Note that there are messages that display in the output when running to tell you that the driver's loaded or the function's been called properly and so forth. Now, if I was to add a new sub-project, you get a number of options. We get a WinCE application, that's just a standard Windows application, form-based but not .NET. We could create a console application, which is a native application. It just runs at a command line. We could create a dynamic linked library. Typically this might be a library of functions that console or Windows application could use. We could create a static library which could be linked similar to the dynamic linked library, except it would be linked when the console application or the Windows formed application is built. Finally, there's the Tux dynamic library, which enables you to do some testing with the operating system. If we build a stream driver, it actually is a dynamic linked library of a certain structure. Now, this is where my gripe is. Wouldn't it be real nice if this interface, that the structure of these sorts of projects, these wizards, was available, and you were able to add like a stream driver, you're able to add a stream driver load application, stream driver unload application, stream driver test applications, stream driver test UI octals, and so forth. Wouldn't it be nice if this structure was available and we're able to add our own custom functions? Now, each of those available templates is just a simple DLL in one of the platform builder directories. What would be nice is if we could add our own DLLs with our own templates, and so we get something like a stream driver wizard template being available when this is open. And that's my wish. That's what I would like. Now, to that end, to a certain extent, I first created the CEDriverWiz, and I'm now making available the CEDriverWizTemplates. Let's just have a brief look at CEDriverWiz. Now, essentially, a stream driver project is a set of files which are all text. There's a VIF file, there's the CPP source file, there's header files, registry files, and so forth, but they all are just text files. And so it's just a matter of creating some sort of program that will enable you to generate the required files, having fed in, you want a certain prefix, you want a certain driver name, and so forth. Let's now look at the second gripe of mine, running sub-projects. We can run sub-projects in a number of ways. On the device, we would just open a command prompt and run the sub-projects that way. Within Platform Builder, we can actually directly run or orchestrate the running of these sub-projects from Visual Studio itself. We can, from the target menu, choose to run programs, in which case we get a list of programs to run there, or we can use the target control where we just enter S and space and the application name. Let me just add a suite of sub-projects to do with one particular stream, that is the stream driver itself and its test application. So you note that you might have seen that in the previous screen I actually just selected a DIRS file which actually specifies all these sub-projects, so I can load them as one. That will be covered in subsequent videos. So here we have with the suite, we have the test applications. There's the stream driver itself. There's a basic test application which just tests that the driver was loaded. This is the application that actually loads the driver for us, and we can reload it. difference between the two is this one actually puts the required registry settings into registry for the driver. This one uses the existing ones. And we have our test application. The basic test application here just sees whether it can actually open and close the stream. This one opens the stream, writes to the stream, reads from the stream, closes the stream. This application tests that it can actually write certain ioctls to the stream driver. And finally, this application unloads the driver. These are all generated by CEDriverWiz or CEDriverWizTemplate, depending upon what name you give to the stream, what prefix you use, and various other things. So let's now just look at the running of these. We don't directly run the stream driver, we run the application, say, to load it, to unload it, to test it, and so forth. Okay, so now wouldn't it be nice now if we could just right click on, for example, the load application and say run. There's a run code analysis, but it's not run the application on device. What we have to do is either go to target control or run programs, or via the command prompt on the device from there to run the program. So let's start by loading the stream driver. So we go to my stream and we load it there, the stream load app. So we run that and we see that it loaded okay. This is a message generated by those messages that right through all these applications. Let's now test that we can open and close. So we target, run programs, the basic test. So you can see that it opened and closed okay. So the driver seems to be like. Let's run the more detailed test where it will read and write to the stream. So it wrote this message, it wrote to it and read to it. It read okay, the number of bytes read was the number written, so all was well. So it's able to read and write to that buffer. Let's test the ioctls. We see down here that the various ioctls are running. It sent 10 ioctl calls, 5 of them work, and that's 5 that are implemented in the stream drive, so all's well. Let's now unload the driver. It's unload the driver okay. Let's just try reloading the driver. Yeah, it loaded okay. Okay, so we can run programs from this menu. We can also run from target control. So if we want to run an application here, we just as in start, put the function there, and it was able to open and close the stream. So From Visual Studio we can run applications using target control or run programs, but as I've said a few times, wouldn't it just be nice to actually right click and be able to run here? So that's finishing my second gripe. The first gripe being just able to add custom projects into that directory as DLLs. Now, to address the first problem, adding custom projects, the first version of this wizard, CEDriverWiz, was implemented as an add-in to the tools menu. CEDriverWiz is essentially just a standalone application which goes and generates all the required files and sets up the text within them to use the required stream name, to use the required prefix and so forth. So when that's installed, if you choose the right options, you get the ability to run it from this menu here. So it runs, and you'll see you get this form where you can actually choose various things. Choose what functions you want to use, whether you use retail messages, debug messages, what sort of IAC tools you want, and so forth, and then choose which of those functions, those applications, sub-projects that you want to use or implement. This new wizard, CEDriverWizTemplates, goes a bit closer to the bone, bit closer to being integrated, like what I said, as in adding from here. What you do is right click and say add new project, and you'll see that under Platform Builder not only is there the operating system design template, but there are the various templates. And so you get your basic stream, that's your driver there, and so forth. So you can actually do each of these individually. The actual using of this will be the subject of the third video. Okay, so there are my gripes. The wizard addresses this first issue of having custom third-party sub-projects apart from the ones that come out of the box. Some resources. I'm co-author of this book, which is available from Rocks. I co-author this with Sam Fung and Thierry Jouvet. Other resources is our embedded101.com site. Various particularly Windows CE, Windows Embedded Compact resources are there, and its readership and input is growing by the day. Finally, there's the Microsoft Windows Embedded site. In particular, look for the white papers there to do with device drivers and board support packages. They are extremely useful. The next video will quickly address the setting up of CEDriverWizTemplates.